This question asks us to show a mechanism for this alcohol formation reaction. This is a hydration of an alkene. So the first thing that's going to happen when we have water and acid together in solution is that water is going to be protonated by acid to form H3O+. And this will be our acid that carries the reaction through. The next thing that's going to happen is the alkene is going to attack the acidic proton, and the alkene is going to get protonated. This is showing this step in regular arrow notation. We can also show this step in bouncing arrow notation, where the electrons stay with the terminal carbon to attack this hydrogen, forming the carbon-hydrogen bond to the terminal carbon. That's going to take electrons away from the internal carbon, leaving behind a carbocation in that position. So let's go ahead and draw in the carbocation intermediate. So this is the carbocation intermediate. This intermediate can be stabilized by resonance. So if your instructor wants you to draw additional resonance contributors, you would draw them here. I'm not going to draw them to save space and time. Next thing that's going to happen is the water nucleophile can use a pair of electrons to form a carbon-oxygen bond with the carbocation. That's going to form our key carbon-oxygen bond in our alcohol. I don't have any electrons showing the loss of any hydrogens from water, so oxygen will bring along both of its hydrogens. Therefore, it will have 3 bonds and a positive charge. The last thing we need to do then to get to the product is neutralize this intermediate, and we can do that with another molecule of water. Another molecule of water can take an acidic proton to form our desired product, finishing this mechanism. This is the mechanism for the hydration of an alkene.